So looking at this example, again, this involves direct variation as well. So a can of tomatoes contains 794 grams, and the cost is $1.59 for that. Use proportions to find the constant of direct variation for the cost per gram. So this is kind of some important information. Cost per gram. That ratio is going to be key because that's going to be our constant direct variation. So it does say round to the 10,000th place if necessary. So notice how our directions, if I want to find the constant direct variation, identify a pair of related data in which both values are known. So notice how we have this 794 grams and the cost is $1.59. So that's kind of our related data. Write the data as a ratio. But notice how cost is on the top, grams is on the bottom. So the $1.59 is going to be on the top. The grams is going to be on the bottom, 794. So what I want to do is find the cost per 1 gram. To do that, we just divide this out, and that'll be the cost per 1 gram. Notice that the independent variable is the denominator because the cost depends on how many grams I purchase. So that's going to be important to us. So they also have this formula, K equals Y over X, where Y represents the dependent variable and X represents the independent variable. Usually we have what's called input-output. The input is what goes to the calculations, and the output is dependent upon the calculations. So a lot of times X and Y are used in that situation. So it says leave the ratio as a fraction or change it to a decimal equivalent. It looks like here they want us to change it to a decimal equivalent. So what we need to do, let me see if I can get my numbers back over here. So we have $1.59, and we have to divide that by 794. And we get then 0.00. So we do get a big number here. So it does say round to the 10,000th place. So remember, the ones places here, then there's the decimal point, and then you get into the decimal place values, tenths, hundredths, thousandths, 10,000ths. So they want us to round 4 decimal places, which means I have to look at the 5th decimal place in this problem. So if we go 1, 2, 3, 4, the 5th decimal place is a 0. So it looks like we're just going to have 0.0020 as our answer if we round to the 10,000th place. So 0.0020. So K in this problem would equal then 0.0020. That would be our direct variation. So what that's saying is, if I use this, that's basically the cost per 1 gram. So if I multiply that by 794, that should give me a cost of $1.59. So if I bring back my calculator, so this 0.0020, if you will, that's the cost per gram. If I multiply by 794 grams, I should get around $1.59. So that's how if that rounds up, it would be $1.59, since we did do a little bit of rounding here. So that seems to play out right. So in this case, the constant of direct variation is basically like a unit rate. So that's kind of what we're seeing there.